Dear students, let us start a new chapter whose name is alternating current. So before going to the alternating current, let us talk about the direct current first. So direct current, we have studied that it is a current whose magnitude do not change, that is the magnitude remain constant for all the time. If it is 2 volt, then in 1 hour it will remain 2 volt, in another hour it will remain 2 volt, in another 1 hour it will remain 2 volt. Similarly, if the current is 3 ampere, for all the time the current will remain 3 ampere. Okay, so that is our direct current. Now in alternating current, so alternating current means the current which get altered, its direction will change, its magnitude will change. So let us begin with a small experiment to understand the alternating current. This is simply the introduction of the chapter. To start with, let us consider a galvanometer here, okay, which measure the voltage or currents, and let us have an AC source and a key like this. Okay, so this is my AC source. So now onwards, this will denote our AC source. Okay, for all the lessons in this chapter, whenever we see this kind of diagram, this type of figure, we understand that this is my AC source. And what is it? This is our galvanometer. So what happens in the galvanometer? In galvanometer, we have this reading, okay, say 0, 1, 2, 3. This is 1, 2 and 3, and this is also 1, 2 and 3. Okay, for more convenient, I will write this is -1, -2 and -3, and we have this pointer of the galvanometer. Now I switch this on, I make this circuit closed so that the current will start flowing. So let us make a small table here. Let me write this as current. Okay, let me write this as time in seconds, and a current, current, current I in ampere. Okay, now whenever we write one more thing, the terminologies, if I write capital I, then it will represent to the direct current, and if I write capital V, it will represent to the direct voltage. Now if I write simply small letter I, then it will represent to the alternating current. If I write a small v, then it will represent the alternating voltage. Right? So these are the two things that we should understand. Capital letters are reserved for the direct, and the small letter are reserved for the alternating currents. Now in first time, say 1 second, let us, okay, in 0 time, the current is 0, it is pointed at 0. In the first 1 second, let us it move to this point 1. Current is 1 ampere because there is a deflection in the galvanometer like this in 1 second. In another 2 seconds, let it reach to the second, and in third, let it reach to 3. Okay, in each 1 second, the current is increased by 1 ampere. Okay, in 0 second, we have 0 ampere, 1 second, 1 ampere, 2 seconds, 2 ampere, 3 seconds and 3 amperes. We are just doing an observation to an experiment, to the hypothetical experiment you can say. And in 4th second, now what happens is, very interestingly, this has reached here in 3rd second, now it will come to the second. Okay, it will become 2. It means that it is now decreasing. In the 5th second, it will go to 1. 6th second, it will go to again 0. Okay, so what it did is, first it went in this direction till the third 3 ampere, and it came back to the 0 at 6 seconds. Okay, now what it does is, again now it will start moving towards the negative side. Now we have reached to the 6th second, and now in 7th second it will go to the -1 here, okay, here, and in another 8th second it will go to -2, 9th second -3. It is reached this point now. Now in 10th second, what does it do is, it will again go back. It will again go back to -2 ampere, okay. In 11th, it will go to -2, and in 8, 9, 10, 11, and in 12th, it will go to -1, and in 13th, it will go to the 0, okay. 5, 6, 7, 8, 9, 10, 11, whatever it is, okay. So this is the observation that we see in the deflection of the galvanometer whenever this galvanometer was connected with the AC source, okay. Now very interestingly, what we see is from 0 it reached to this 3, which is increasing. The current increases from 0 second to 3 second, okay, and from the, once it reached the maximum value over here, it started decreasing till 0, okay, and then it decreases from where 4 to 6, okay, like this. First it increased and again decreased, and again it went to the negative side till -3, and it again came back to 0 till 0, okay. So this is called alternating current. Why alternating current? Because it is increasing and again decreasing. At the same time, it is also reversing its direction. For an example, it was going to this, and it can reverse back, and it went here, and again it reversed back, okay. So what is an alternating current? Alternating current are those currents whose, okay, very important, alternating current में क्या होगा? The magnitude gate changes periodically, okay. Periodically means in 1 second it reaches to 1 ampere, in another 1 second it reaches to 2 ampere, in 3 seconds time it reaches to 3 ampere, and it changed its magnitude periodically, okay. And next is it reverses its direction periodically, okay. So this is also very important. So there are 2 points which we should understand in alternating current, is that the direction will change, direction will reverse periodically. It was going from 0 to, okay, it went from 0 to maximum to minimum, again from negative it was positive and negative, okay. It is increasing towards positive, decreasing, and again it is going towards negative and decreasing. So it is reversing the direction. So what happens is it reverses its direction periodically, okay. So that is this. Now if we want to draw a graph of this current, then how would it look like, okay. So the main thing is that what happens is, let me have this this diagram, say T, and this is my current I, okay, positive I, and this is my negative I. Why I am writing positive I and negative I? Because if we see here, there are positive values of current as well as the negative values of current. Therefore I am plotting here positive and negative, okay. I can put here 1 second, 2 second, 3 second, 4 second, 5 second in the time, and I can put 1 ampere, 2 ampere, 3 ampere in the current axis, but not plotting the exact number. Let me just figure out what happens here is, from 0 to 3, what happening? It is increasing, isn't it? 1, 2, 3, 4, okay. Similarly it is increasing here, it increased to this, and this is the maximum it has reached, isn't it? 3, and from 3 it is decreasing to 0, understood? It started from 1, increased to maximum 3 here, and it again decreased to 0. So this is my 0, and it will went here and reached to again 0, okay. We are here. Now what happens is, this is my positive side, okay? From here it is positive, from here it is negative. Now whenever we see here from 0, it is going to the negative side till it reaches -3. Now it will go down to this point. So this is negative, -3, this is positive, +3, -3. Again what happened? It went to from this 0 to -1, -2, -3, -1, -2, -3, and again it went to -2, +1 and 0. For an example, if it is -3, then it will go to -2, -1 and 0. So this is how the graph looked like, right? So this is the graph of alternating current. Now if we see here, then what happens is the current started from 0 and is reached to the maximum, and this maximum we call this I0 and plus I0, and this maximum, okay, which is at the negative side, is minus I0, and this is plus and this is negative, which makes a complete cycle. Okay, it started from 0, increased to the maximum value, again went to the 0, again reached to the maximum negative, again go to the 0. So this is the plot of the alternating current. This is how it looked like. Now now let us tally this graph with some other function. Now if we also draw, okay, if we take sine of theta, okay, sine theta and its plot, the graph of sine theta will similarly look like this one. Okay, graph of sine theta means if I put sine 0, I will get some value, sine 0 is 0, and sine 30 I will get some value, sine 45 I will get some value, sine 60 I will get some value, like this. And if I go on putting these values and if I plot it here, then I will get this kind of graph, which is same as this, isn't it? So this graph is sinusoidal graph, sinusoidal, sinusoidal graph. So how it means that the graph of the alternating current look like a sinusoidal. So we represent this by a sinusoidal graph. Understood or not? Yes, you should understand now. It started from 0, reached to the maximum, came down to the 0 and went it to the negative maximum and so on. Now how to represent the current now? Okay, if I write this, it means that this current I is proportional to sine of some angle, sine of say some, okay, omega t. I will directly write it. Okay, it means why I am writing sine omega t is because that the current, the plot of AC is sinusoidal. Okay, why I am writing I proportional to sine omega t? Because the plot is sinusoidal. It means that if I plot sine theta, I will get this kind of graph, which is same as this. So the nature of this current should something which should be something like sine omega t. It should give the nature of, if the graph of the sine theta is this one, which is also the graph of alternating current, then in alternating current I, there must be some term sine omega t. Okay, sine of angle theta. So this is called phase. Okay, I will just write where omega t is phase. I will give you the lesson on phase also, just don't worry. Omega t is something, it is called the phase, okay, and phase means some angle, okay, because if I have sine theta, what is theta is angle, and phase is also an angle, okay. I will explain this angle later on. And I want to replace this proportionality constant. So what I do is I is equal to, I will just write I0 sine of omega t. So this is how we can represent the alternating current. So here I will write, this is the graph of I is equal to I0 sine omega t. Okay. Now what is I0? This is the maximum magnitude of the alternating current, isn't it? The maximum is plus I0, minimum is minus I0, okay? So if I write I0, in some book it may be written as I max or it may be written as IM, okay? Everything is fine, but I prefer to write I0 and write where I0 is maximum value of alternating current, that is AC. So that is all about the introduction of alternating current. Now there is one problem. Now we say that the current, whatever current we are consuming in daily life in our houses are all alternating currents. Now, and we say the current is 1 ampere, we say the current is 5 ampere. Similarly, the voltage is also have the same diagram, okay? AC voltage will also going to have same kind of thing, okay? So this is V0 and this is minus V0 and this is T and this is V equal to V0 sine omega t. You can also write this one, okay? Everything is same for current and voltage. Similarly, and we say that every time the current and the voltage that we are using in our everyday life is alternating current and alternating voltage. And we say that I am getting 240 voltage AC, I am getting 220 voltage AC, I am getting 3 ampere AC. Then how we can say that there is particular value? Example, if I say I am using 240 voltage, okay, in India we are getting the voltage of 240 to 250, or mainly we say it is 250 volt. Now if it is alternating current, then in alternating current what is there? There is 0, there is some value and there is some maximum, again some minimum. Then which voltage is we are referring as 2 volt, referring as 250 volt, referring as 1 ampere, referring as 3 ampere of current, okay? So that is very important point here, because the current is changing. If I say I am getting 3 ampere of AC, 3 ampere of alternating current, but if I see here the current is going from 0 to the maximum, again 0, again to the negative, then which value I am referring to? This value is called root mean square value, which we are going to study later on. So this is the introductory part, okay? So similarly we are getting the alternating current in our everyday life, which passes through different devices like resistor, inductor, capacitor, etc. So in the next lesson we are going to see what will happen to this alternating current when it passes through a resistor.